Turning to slide 3, I will give you a bit of history behind this paper of Wheaton et al. Took place 46 years ago at the University of Wisconsin, Madison, Wisconsin, during the academic year of 1974 to 75. At that time, I was a graduate student in statistics at the University of Uppsala, Sweden, under the mentorship of Carl Jurskog and Anders Christofferson. Back then in Sweden, there were not any SCM researchers, and mostly we got our data from the US. And I was curious about going to the US and connect with some people who had interesting data sets and problems to come up with, be inspired to come up with new statistical modeling for my dissertation. And I visited with a colleague of Carl, namely Art Goldberger, who was in the Department of Economics, which is on the right here, to the right of the bell tower. And Art Goldberger had interacted with Carl Jurskog several times in the structural equation modeling area. They had a paper together, for instance, in JASA, Journal of the American Statistical Association, on mimic modeling from an econometric and a psychometric perspective. And there was also the Department of Sociology housed in that building with Bob Hauser, for instance. And one of the first days I came into Art Goldberger's office with a beautiful view of the lake, he pulled out a note, a couple of pages that been put together by the sociologist Otis Dundee Duncan, where he had formulated a problem that he didn't solve that had to do with dichotomous dependent variables in a structural equation model. So that was fortunate. He provided the data as well, and I came up with the modeling, and that became the first paper in my dissertation and got published in JASA, my first and only JASA article. But that article didn't become very well known. Instead, another paper that was created during that time became very well known, the so-called Wheaton et al. Article. So that came from an interaction with Blair Wheaton, who was a graduate student in sociology at that time. A very hard-working guy who had data from Alvin and Summers and was struggling with structural equation modeling efforts, trying to find a reasonably well-fitting model. And I came in at the right time there to help along with the modeling and the literal runs. And out came eventually this paper. The model is like this. We have measures anomia and powerlessness, measuring an alienation construct at 3 different time points. And we have an SCS construct measured by education and a socioeconomic index created by Otis Dundee Duncan. And Blair's contribution here was to estimate the stability between, that is the regressions between these factors over time, controlling for SCS, and also adding measurement error to the indicators, the outcomes here, thanks to having multiple indicators. My contribution was, I just learned about this in Uppsala, to say that, well, you really should allow for correlations between the residuals, the errors of each indicator at least adjacent time points like this, for the first indicator and for the second. And that enhances the fit quite a lot, picking up a lot of influences, time-specific and item-specific influences that are omitted, that are unobserved variables, and therefore get picked up by the residual, and needs correlations among the residuals. Now, it's easy to criticize this model in hindsight, and I do so in our M+ short course topic 1 video from Johns Hopkins. You have a 2009 recording, for instance, with slides 231 to 238 being the relevant ones. And the major problem here is, of course, that you only have 2 factor indicators. And that's not a desirable situation. You should try to avoid that if you can. Because what you want to do when you have a model like this, you want each part of it to be correct. And you have many parts here. You have this measurement part, this measurement part, this measurement part, this measurement part. Preferably, you want to test each of those parts and combinations of the parts as well. But you can't in this case because you have only 2 indicators and you need 3 indicators for the model to be just identified. And in that case, you can't reject it because it is just identified. So you really need at least 4 to be able to test it. So the fact that you can't test it means that you may introduce various kinds of misspecifications in the model that then may spread and not only affect the measurement part but also the structural part. So I discussed that in the topic 1 video. In our defense, Blair's and I, we actually started with more items to begin with, but it was hard to find a unidimensional construct for some of the items. So we boiled it down to 2, and it became an article that at least was a good example of a new kinds of structural equation model, although it's not the strongest one due to having only 2 indicators. Another critique could be that this construct is not really perhaps believable. It says that you have inside of you some sort of SES dimension, and as it increases, you seek higher education and higher paying jobs. Whereas perhaps a more natural way of looking at it is that you have an education that may influence the job that you take, and that builds up your SES status. So the arrows go the other way, and instead of having what's called reflective factor indicators, you have a formative situation, which might be better. Now, putting that aside, it's still a good example of the key issue of a longitudinal SEM, 3-time-point SEM. And let's see what we can do with that. Now, in the standard situation, the standard model version here would be that you have metric invariance for the measurement part. That is, time invariant factor loadings. So these factor loadings are equal across time. That's necessary, of course, to make sure to some extent that you have the same construct in the same metric. And also correlated residuals, like I mentioned, for each factor indicator and at least for adjacent time points. So that's what I would call the classic version of the Wheaton et al. Model. In our article, Blair and I went into all kinds of contortions to find a more relaxed model that fit better, but I think this is sort of a good point to stop at. Chi-square is 90 with 13 degrees of freedom. So we reject the model with the help of the p-value being 0, although this is 900 individuals here. So it's a fairly large sample, fairly strong power, ability to reject the model. The RMSEA is also not great. CFI is good, but that's a very forgiving index in many cases. Now, turning to the next slide. What if I told you that in addition to the classic model, there is a new model which has 6 fewer parameters, more degrees of freedom, that is a more restrictive model, but still a better chi-square? Well, that's the model that I stumbled upon recently, some decades later. It has a much better BIC because, lo and behold, despite the lower number of parameters, you have a higher log likelihood, and therefore you have a much better BIC, the better chi-square, actually a little p-value here at 4%, NRMSEA that goes down very nicely, and almost a unit perfect CFI. So what I want to do in this web talk is describe how this new model comes about and show you the picture of it and show you how to set it up in M+.